In our third part of review here, let's talk about trig identities. Okay, the, we already know from what we did up here that the tangent is sine divided by cosine, and cotangent is x over y, or cosine over sine, and they're reciprocals of each other. Cosecant is the reciprocal of sine, secant is reciprocal of cosine, and tangent is the reciprocal, cotangent is the reciprocal of tangent. Then they say sine squared plus cosine squared equals 1. Well, if we go back to the definition and the unit circle that we had here, if sine is the vertical side of this, and cosine is this side, Pythagoras says the sine squared plus the cosine squared would equal the hypotenuse squared. But if we're on a unit circle, that's 1. So sine squared plus cosine squared equals 1. Or cosine squared plus sine squared equals 1. That's the fundamental trig formula for Pythagorean theorem. Now, there's a lot you can do with that. If you take sine squared theta plus cosine squared of the angle equals 1, and it doesn't matter what the angle is as long as they're both the same, the sine squared of any angle plus cosine squared of the same angle will always equal 1. If you divide all these by cosine squared, you come up with a new identity. Sine over cosine is tangent, so this is tangent squared of an angle plus 1 equals 1 over cosine. 1 over cosine is secant, and this is squared, so it's secant squared theta. Okay? Which is that formula. Now, you can do things with these formulas. Let me get this next one here. If we started with sine squared theta plus cosine squared theta equals 1, and divided everything not by cosine squared, but by sine squared, sine squared divided by sine squared is 1. Cosine divided by sine is cosecant, and this is squared, so this will be cosecant squared theta. And 1 over sine is cosecant. Cosine over sine is cotangent. And 1 over sine is cosecant. Now, we can take these and do all kinds of work on them. For instance, if I have sine squared plus cosine squared equals 1, if I subtract sine squared from both sides, I would get cosine squared theta equals 1 minus sine squared theta. And this can factor. This would be 1 plus sine theta times 1 minus sine theta. Not often you do that, but that does equal this. So this times this is the same as cosine squared. That's if we subtract sine squared from both sides. If we subtracted cosine squared from both sides, we'd have sine squared theta equals 1 minus cosine squared theta. And we could factor that. If you took this one, tangent squared theta, and subtracted 1 from both sides, you would see that the tangent is equal to secant squared theta minus 1. Or you could subtract secant squared from both sides and subtract 1 from both sides. You would have tangent squared theta minus secant squared theta equals minus 1. And there's other things you could do algebraically for this. This actually factors the tangent of theta minus secant of theta and tangent of theta plus secant of theta. And you could also come up with different variations of the cotangent equation. Cotangent squared theta is equal to cosecant squared minus 1. And often in a trig course, you spend a lot of time playing with these and coming up with different ways of rewriting problems. Okay. Now we want to talk a little bit about even and odd functions. So this I'm going to kind of need to get the unit circle over with this, but let's just talk about this. Sine of a negative angle. If I go a positive 30 degrees, the sine will be 1/2. If I go a negative 30 degrees, the sine will be negative 1/2. If I go positive 45 degrees, the sine is square root of 2 over 2. If I go negative 45 degrees, it's negative square root of 2 over 2. So the sine of the negative of an angle is the same as the opposite of the sine of the positive angle. The sine of the positive angles, its opposite of that is the sine of the negative angle. So we call sine an odd function because you could change the sign of the argument, change it from a plus to a minus, it changes the sign of the whole function. Whereas cosine of a negative angle, it doesn't care. Look, if I take the x value for 30 degrees and the x value for negative 30 degrees, I get the same x value. If I take the x value for 45 and negative 45, I get the same value. If I take the cosine or the x value for 120 or negative 120, I get the same x values. So the cosine is considered an even function. You can change the sign of the angle, and it doesn't change the value of the sine, of the cosine. It's the same value as the positive angle. Since tangent is sine over cosine, and the numerator will change and the denominator doesn't, the tangent is an odd function. Since the only difference between sine and cosecant are reciprocals, they have to be odd function. And the only difference between cosine and secant is reciprocal. So since cosine is even, so is the secant. And since tangent is odd, cotangent is odd. So that's those. Double angles and half angle formulas. Well, to get these, let's first go to product and sum. Not product formulas. Where is it? Sum and difference formulas. These are the most common ones that you need to kind of be familiar with on these. Over here, these are not going to be as important. But these and the half angle and double angle. So let's go to here. Now, let's talk a little bit about the sine of an angle plus an angle. I'm using alpha and beta here, but it could be x and y or theta and something else, whatever. But the sine of two angles added. So this is a function. Let me first explain why you can't just go sine of this plus the sine of that. If I had the function f of x equals x squared, and I said, what's f of 2? You would tell me that's 2 squared, or 4. If I said, what's f of 2 plus 2? I hope you wouldn't say, well, that's going to be 2 squared plus 2 squared. That would come out to be 4 plus 4, or 8. But that's not what it is, because 2 plus 2 is 4, and it would be 4 squared, or 16. Functions do not distribute over their argument. You cannot distribute. There may be an occasional time it works, but the, there is no rule that says a function will distribute. There's only certain circumstances that it ends up being the same. So what is the rule for sine of two angles added? It's kind of a messy derivation in trig class, but it turns out that you have to do the sine of the first angle, cosine of the second angle, and if this is plus in here, it would be plus cosine of the first angle, sine of the second angle. Sine of first, cosine second, cosine of the first, sine of the second. And if this happened to be a minus, that just changes this to a minus, which they show you in this one. Now, what do you do for cosine of two angles added? Well, that one turns out to be the cosine of the first, cosine of the second, minus sine of the first, sine of the second. Once again, I'm not deriving this. I'm just telling you that's what you have to do if you got plus. And if this was minus, this is plus. So you can see the cosine of them added as a minus, and the cosine of them subtracted, you get a plus in here. And it's cosine, cosine, sine, sine. Cosine, cosine, sine, sine. For sine, it's sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Of the first, second, the angles. So those are the sum and difference. Now you can do the tangent one. You can come up with this formula by just doing sine of alpha plus theta over the cosine of alpha plus theta and simplify, and you can come up with that one. But there's the rule for tangent and the tangent of angle subtracted. Those rules exist. The most important ones are for you to remember what to do for sine and cosine of angles added and subtracted. Okay, now, the last ones that I'm going to do here on identities are the double angle formulas, and I might do the half angles here. Double angle. So if we have the sine of 2 theta, that's the same as the sine of theta plus theta. That's what 2 theta means. 2 thetas added. And so if I use the formula for the sine of 2 angles added that I just talked about, that becomes the sine of the first one, cosine of the second one. And if it's the sine function, it's the same operation, positive, adding, and then it's cosine of the first, sine of the second. And you notice this is the sine times the cosine, this is the sine times the cosine, so we get 2 sine of theta cosine theta. So 2 times the sine of theta times the cosine of the angle is equal to the sine of 2 times the angle. That's this first identity. And you can use that to change this or change sine times cosine to somehow relate it to sine of twice the angle. Cosine of twice the angle, if you just follow the same process, cosine of 2 theta is cosine of theta plus theta, which would be, according to the rule, cosine was cosine, cosine, sine, sine. So it's cosine of the first, cosine of the second, and cosine, the operation changes from addition to subtraction, and we get sine of theta, sine of theta. So we get cosine squared theta minus sine squared theta. That's the fundamental one. Now, we talked earlier about the sine squared plus cosine squared equals 1, so cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. But you make those substitutions, you get these two other formulas. For example, here's the first one they gave you right here. This one, all they're doing is replacing the sine squared with 1 minus cosine squared, because sine squared theta plus cosine squared theta equals 1. Sine squared would be 1 minus cosine squared. So if we put in 1 minus cosine squared there, we get cosine squared theta minus 1 minus cosine squared theta, which turns out to be cosine squared, and minus minus is another cosine squared. We get 2 cosine squared theta minus 1. That's this identity. And if you replace the cosine squared with 1 minus sine squared, you'll get that identity. And if you do sine of 2 theta divided by cosine of 2 theta and do a little algebra, you will come up with that identity for the tangent of 2 theta. The half angle formulas come from these. This one and this one. Okay, and there's something that always confuses students about that, so I'm going to do this. Cosine of 2 times the angle is 2 cosine squared of the angle minus 1. Well, if it doesn't matter what this angle is, I could replace it with x over 2. So then this would become cosine of x over 2 times 2 would just be x is equal to 2 cosine squared of the angle x over 2 equals 1. So if I solve for the cosine of x over 2, I would subtract 1. And then I'd have to divide by minus 1. Then I'd have to divide by 2. And now I'm down to the cosine squared of x over 2. So I take the square root, and when you take the square root, you get plus or minus, is the cosine of x over 2. And that's how they get this formula. And if you went back and took this formula right here for the cosine of that and made this x over 2 and this x, you would come up with this formula. And you can take this one divided by this one, sine over cosine, and you can come up with a tangent one, which is, there's multiple forms. That's the easiest one to do. So those are all the identities that are the basic ones. There's some other ones that we can use, and then there's finding areas and ratios of sides on triangles, the law of sines, and cosines. Let's talk about that a little bit. It turns out that if you have any triangle with any sides A, B, C, and if the sides across from the angle B is B, and across from C is C, and from across A is A, notice they labeled the angles with capital letters, the sides with small letters. It turns out the sine of the angle A compared to the side opposite, that ratio is the same as the sine of B is to B, or the sine of C is to C. Excuse me, that's called the law of sines. And then the law of cosines, they do it several times here. This is, in the Pythagorean theorem, it's often written a squared plus b squared equals c squared on a right triangle. But what if you don't have a right triangle? Well, you notice you have a squared, c squared is equal to a squared plus b squared plus an adjustment. And this is the law of cosine is the adjustment on the Pythagorean theorem for any triangle. So it's, if you think about it, this is the way I like to teach it and have students think about this. If you have an angle and you have two sides adjacent to the angle, then if you take the two sides adjacent to the angle, so if you go a squared plus b squared, square the two sides that are adjacent, then go minus 2 times those two multiplied, times the cosine of the angle between those two sides, you get the side across from it squared. If I went to A, the two sides next to it are B and C, so B squared plus C squared minus 2 times BC times the cosine of the angle between those two sides. That will be the side across from it squared. So this relationship between the sides and the angles can be used if you know one angle and two sides next to the angle, you can get the other side. If you know a couple of angles and one of the sides across from it, you can get the side across from the other. Or if you know an angle and two sides, you can use the ratio of those in the law of sines to solve triangles. So there is the rules for solving triangles. Okay.